Right-angled triangles occur frequently in problem solving. Anytime you can identify a right-angled triangle, you should check whether Pythagoras' theorem can be used to help solve the problem. In this video, we'll look at the methodology for problem solving with Pythagoras' theorem, followed by a few examples. Just a reminder that in a right-angled triangle with legs A and B and hypotenuse C, Pythagoras' theorem says that a squared plus b squared equals c squared. When solving problems with Pythagoras' theorem, we can follow a few steps to help us solve the problem. First step, identify and draw a right-angled triangle which may help solve the problem. Second step, label the sides with their lengths or with the letter pronumeral if the length is unknown. Use Pythagoras' theorem to solve for the unknown. Then solve the problem by making any further calculations and answering in words. Here we have an example. A ship sails 20 kilometers due north and then 35 kilometers due east. How far is the ship from its starting point? The first step is to identify and draw the right-angled triangle, which may help solve the problem. Then label the sides with their letter or pronumeral if the letter length is unknown. So we draw our triangle, that it sails due north 20 kilometers and then due east 35 kilometers. Now we can draw a right-angled triangle and label the side x. Now we're going to use Pythagoras' theorem, a squared plus b squared equals c squared, to solve for x, or the distance from the starting point. So we rewrite it as x squared equals 20 squared plus 35 squared, x squared equals 400 plus 1225, x squared equals 1625, and we square root both sides. We write x equals the square root of 1625 kilometers, which is our exact answer in surd form. And we can solve that. We find that the distance from the starting point is 40.3 kilometers. So we write that, because this is a problem solving problem, we write the answer in our words. So the ship is 40.3 kilometers from its starting point. A ladder is 5 meters in length. Industry standards say that the base cannot be closer than 1 meter to the wall. How far up the wall will the ladder reach? This might be important for a job where you know you have to reach a certain distance up the wall, say if you were painting the top of it. So here we draw the triangle in the first step. So you can see that the ladder forms a right-angled triangle with the wall. And therefore we can use Pythagoras' theorem to solve for how far up the wall the ladder will reach. So we write our formula, h squared plus 1 squared equals 5 squared. In this example, the ladder is the hypotenuse, therefore that's the 5 squared. So we write h squared plus 1 squared equals 25. We take 1 both sides, and we get h squared equals 25 take 1. H squared equals 24. We square root both sides, and we find that h is the square root of 24 meters. And we can solve that, and we know that the height is 4.89 meters, and therefore the ladder will reach 4.89 meters up the wall. We have another example. Find the exact distance between the pairs of points on a number plane. The points are x equals 0, y equals 3, and x equals 5, y equals 0. So we plot the points on the number plane, and we draw our line connecting the points. As you can see, this forms a right-angled triangle with the axes of the number plane. Therefore, we can use Pythagoras' theorem to find out the distance between the 2 points. So we know that that's going to be x units. We don't know the units in this example. We solve for x. So the side we've labelled x forms the hypotenuse of the triangle. Therefore, we can write x squared equals 5 squared plus 3 squared. 5 squared is the distance along the x-axis. 3 squared is the distance up the y-axis, or the rise. We get x squared equals 25 plus 9. X squared equals 34. We square root both sides, and we find that x equals the square root of 34 units. In this example, we're trying to find the exact distance, and therefore we'll leave it in surd form, and we write our answer. The exact distance between the pair of points is the square root of 34 units. Thank you.